Welcome! Today, we'll show you how to use CET.SteelConnDesign with FreeCAD to create a beam-to-column, single-plate connection. We'll also demonstrate how to generate 2D drawings for the connections. If you missed our previous videos on downloading, installing, and using our system, be sure to check them out on our channel. First, let's start the portable version of FreeCAD and select the CET.SteelConnDesign workbench. Our goal is to create a beam-to-column web, single-plate connection. To do this, we will create the beam and column by entering the member data after our system is ready. After clicking the Create Member button, both the beam and column will be created. If you need to make any changes or corrections, you can easily modify the members. Please note that the column has not been rotated, and the beam is now connected to the column flange. We can adjust the column rotation in the Connection Design tab. To create the connection from B1 to C1 web, please make sure that Beam to Column Web is selected for Connection Setup. Clicking the Create Connection button will create the B1_C1 connection and add it to the list. Now switch to the Connection Design tab and change the design parts to column. Here we can rotate the column by 90 degrees. Also, we can change the column size to W18 by 85. By clicking the Design Connections button, we will finish the design process. You will notice that the column is rotated and the 3D connection model is displayed in the second window. We can rotate the view to get a better angle to see the 3D connections. Now let's select the beam in the design parts. Here we can change the beam grade, section size, and others. For example, we can set the shear load to 15 kips. After the design, the single plate will be shortened. If we undo the changes, the plate will return to the previous length. We can also change the beam setback to 1 inch. For the column, we can also change the column grade, section size, or rotation. For the web connection, there are 3 tabs: the General tab, the To Beam tab for bolts, and the To Column tab for welds. In the General tab, users can change the grade and connection type. Currently, we support single plate, and soon we will support more types, like end plate. We can change the vertical alignment from top to middle, and as a result, the vertical position of each plate has been updated in the 3D model. We can also adjust the horizontal alignment of the plate to the right side. There are many fields, such as length, that can be adjusted. For instance, the input thickness can be 0.5 inches. Our system has a unique feature where input fields highlighted in cyan indicate that these values are derived from design results, rather than user inputs. Now we align the single plate to the top of the beam and set the distance from the top of the plate to the top of the beam to 1.5 inches. The user can specify either the extended configuration or the conventional configuration according to the AISC manual. If you are not certain about the configuration type, it is recommended to select the extended configuration for the design. Let's go to the To Beam tab. Here, we can change the bolt grade, type, hole type, and bearing or critical type. For bolt diameter, we can leave the field empty and let the system design it automatically. This is another unique feature of CET.SteelConnDesign. After design, the bolt diameter field is highlighted in cyan as a design result. The graph on the left displays the meaning of some fields. For example, we can locate the To Connection Face Transverse to Load field in the diagram. We can modify its value to 3 inches. Additionally, we need to ensure that there is no input value for the plate width. After the design, the horizontal position of the bolts is adjusted, and the plate width is updated in the 3D model. We can increase the plate width by changing the horizontal edge distance to 2 inches. Clicking Undo button twice will restore the connection dimensions to its previous values. For the To Column tab, we can specify the single plate to column fillet weld size. For example, we can enter 0.375 inches. That concludes the process of designing a beam to column single plate connection. Thus far, we have covered the process of using FreeCAD and our system to design connections and visualize them in a 3D model. Next, we will utilize FreeCAD to generate 2D engineering drawings. To get started, select the TechDraw workbench. Then click the Insert Default Page button on the toolbar. This will add a 2D drawing page to our 3D connection model. Then select the solid window, set it to front view, and select B1_C1_WebCon in the Model tab, Solid 1. Clicking the Insert View button on the toolbar adds a 2D plate front drawing to the drawing page. In the Model tab, change the page scale to 0.3. This will ensure that the plate front drawing fits better on the page. You can adjust the drawing positions. To add the second view, select the right view in the solid window. Then, go to the Model tab and select B1_C1_WebCon in Solid 1. Click the Insert View button to add the right view of the plate to the drawing page. By repeating previous steps, we can add more views to the page, even the 3D projection view. If you add unwanted view, you can just delete it. Please refer to the FreeCAD manual to learn how to customize the default drawing page and page templates. For 2D engineering drawings, it is necessary to add dimensions. Now we will add the width dimension for the plate. Select the start point, then select the end point while holding the Control key. Then click the Insert Horizontal Dimension toolbar button. A horizontal dimension, 4 inches, is added. By repeating similar steps, we can add a vertical dimension, 8.5 inches, to our drawings. After adding views to our drawings, we can export the drawing page to DXF or SVG format for later use. In the CET.SteelConnDesign tab, clicking on Show Solids button will let FreeCAD UI go back to 3 window status. That brings us to the end of today's presentation. Thanks for watching.